Hi, in this video, we are going to understand one of the digital modulation technique and to generate the passcode modulation PCM signal using MATLAB and also to plot the passcode modulation PCM signal using MATLAB. This is full coding for example 1. Here we will plot or generate analog signal as a sine signal, and then from this signal we gonna plot sample signal. Next we will encode and decode the signal, and also we are going to plot the square signal. First step we need to do is to create the time matrix from 0 to 3 with the time interval 0.01, and then we make sine wave by using parameter 2 times pi times time. Here is including 1 Hz, which is frequency. Then we are going to make square wave with parameter 2 times pi times 10 Hz times t. For this line, by create the equation, square will equal or less to 0. Next, we will make sample signal by A represent for sine wave, which dot product times P represent for square wave. And for line 7 until line 18, it is according for plot the graph. First, we plot analog signal with subplot 211. Then we plot T against sine wave and X label as a time, Y label as an amplitude, with the title analog signal. For subplot 212, we're gonna plot T against S as a sample signal, X label as a time, Y label as an amplitude, with the title sample signal. The output will becomes like next. For line 20, we gonna plot encode and decode signal. First, we set n as a quantization. For now, we set 3. Y is equal to U encode, represent as uniform encode with parameter S sample signal and n and 1. Then set R equal to U decode as a uniform decode with parameter Y as a uniform encoder and as a quantization and 1. And as usual, line 34 until 35 is the code for plot the output, and with the title encode signal and the second one decoded signal. The output will becomes like lastly, we gonna plot square signal with the title square signal here, but the output will not look pretty. Then we put axis 0 until 3 for x axis, negative 0.25 with 1.25 for y axis. This code to make the limit for output in square signal, and here it is. For example 2, we will talk more in exercise 2.
Now I am going to explain about the exercise question 1 and 2. So question 1, what is the frequency of the analog signal that has been used in example 1? The frequency of the analog signal that has been used in example 1 is 1 Hz for message signal function. As the function declaration, A equals to sine 2 times pi times t, where it shows that the frequency is 1 Hz. So for the second question, generate a 2 kHz sinusoid with a peak-to-peak voltage of 2V. Generate a quantized signal when 8 and n equals to 16 levels. Calculate signal to quantization noise ratio. So let me show this coding in MATLAB. So the quantization value for this coding is 8. To set the interval on time axis, t equals to 0, 0.0001 and 3. For message signal function, x equals to sine 2 times 2000 times pi times t. Quantizing value is 8. To set the mu law value is standard 255. T equals to compend x2551 and mu over compressor. Encoding the signal after quantizing is E equals to U encode Cn. For decoding signal after receiving, D equals to U decode En, while for expand the received signal is O equals to compend D2551 mu over expander. To plot the graph, for figure 1, plot Tx red, plot T0 black, axis at 0, 0.001, negative 1.25 and 1.25. HLEG equals to legend is equals to original signal, received signal using compenting. Hold off. For PCM without compenting, E1 equals to U encode Xn, D1 equals to U decode E1n. For plot graph 2, Tx red, Td1 green, axis at 0, 0.001, negative 1.25 and 1.25. HLUG equals to legend, original signal, received signal without competing. Hold off. Now let me run this coding. So this is the output for figure 1 and this is the output of figure 2. Now for value n equals to 16, we use the same coding which we use for quantizing A. So we have to change the value at here. So n equals to 16. So now I am going to run this coding and this is the output of value n equals to 16. This is figure 1, while this is figure 2.
In exercise question 3 is given to use MATLAB Simulink for question 1. Firstly, we click the library browser to find the block that we want to use. After that, for signal generator, we set the amplitude to 1 and frequency to 1 and unit is hertz. For pulse generator, we set amplitude 1, period 1/10, pulse width 50 and phase delay is 0. Then we connect signal generator and pulse generator to dot product. After that, connect to the scope. Then we double click the scope and see the waveform. So this is the scope that we got. Then we're gonna click again the library browser and then we find the uniform encoder. Then after we connect the uniform encoder, then we double click to run to see the waveform. Then after that, we double click again the library browser to find the uniform decoder. For uniform decoder, we set the bit to 3. Then we run it again. Next, we go to library browser to put another scope. Then we connect the scope 1 to the pulse generator. After that, we run it.
Next, for second example using Simulink, set the block parameter, the amplitude 1 and frequency 1. Set the unit to Hertz. We add for encoder, we pick 1 and 3 bit and also set decoder to put 1 and 3 bits and run the block. So this is the output. Next, using the MU compressor and MU expander, set the MU value to 255 and the peak to 1 to both MU and run the block. So this is the output. Then by changing the block parameter frequency to 2000, set the stop time to 0.001 and run the block again. Open modeling configuration parameter at the solver to changing the type to variable step and run again to see the signal. This is the output after set time to 0.001 and changing the type. Next, 8-bit without compending 2 kHz. Change the parameter encoder to 8-bit and run the block. This is the output without compending. Next, with compending 8-bit, set the compressor to 1 peak. Let's run the block. And this is the output compending 8-bit that have been set. Next, 16-bit without compending 2 kHz. Change the parameter both encoder and decoder for 16-bit. And then we run the block, and so this is the output. And the final, next with compending, add the MU compressor and expander and run the block to get output.